So hello everyone, welcome back. The I hope, like I expect you already know what I am going to do this in the video because of the title. However, the main thing which I basically wanted to clarify before starting the video is that, of course, math is a very of course interesting first of all, and of course very in demand subject. And honestly, me myself, my records in mathematics in the secondary level, and now also in the higher secondary level, it's really not up to the mark. I mean, it's kind of average, and of course, and once I was a very poor student in mathematics. But um, the main thing that I want to, what can I say, show or rather try that how am I actually different? Because I always believed that, and I still do that, each and every problem in mathematics or in every problem in general in life can be solved by your own efforts. Whenever the teacher told that, okay, do this, learn this formula and do this stuff, then the thing which would hit my mind is that how exactly will we know to apply this kind of formula, apply this kind of concept? Of course, the teachers, they will say through practice, of course. But through practice is fine, that okay, maybe similar type of questions come I can do. But what if some different, like the same idea is there but there's some different approach is there? So then how will I do it? So then of course my mind will go blank, because I have not practiced that kind of questions. So I cannot of course do it. So today what I will attempt to do, this is I will show it in PDF also, but this is of course I understand that you cannot read it properly, but this is your, what can I say, IOQM. So basically, it's the Indian Olympiad qualifier. So basically, it's the first stage of qualifying for the International Mathematics Olympiad, especially in India. So of course, I'm seeing through the questions. The first few questions are of easy standard, and basically 1 to 10. The total 30 questions are there. 3 hours of time. 1 to 10 questions are basically your two marker questions, and they're generally easy. And as we go further, they would, of course, the level of difficulty will increase. So the main purpose of this video is to show that each and every problem can be thought of fundamentally, and not like, okay, learn this and this kind of thing will happen. Like each and everything, of course, maybe you will require a much more, what can I say, subject depth to solve it faster. But I'm not talking about speed. Of course, in such exams like this, speed is also a factor. But the main aim of this today's video is not just me solving, looking at solutions and solving this kind of paper. It will be me attempting those problems and showing, forecasting you that it's not necessarily, um, it's not necessarily like that you need some extra knowledge. Because in Olympiad I also, of course, many of my friends, they are into various Olympiads, and they have gone up to INMO level, basically the pre final of, basically, you can say, qualifying for the International Mathematics Olympiad. So of course I've talked with them, and honestly, they are not something extraordinary in the sense, of course, they put in the effort, and they of course have much more, some wave of constructed ideas in their brain. However, but the basic thing is, basically solving each and every problem to its fundamentals. Like, if we just mug up the formula of, let's say, AP, and of course in exam we need it, but if we just mug up, then if we don't know about the history or from where it actually came from, then let's say some other type of kind of series or something is given, we won't be able to think on our own. So the main aim of this is to forecast, or rather show or highlight, that each and every problem, even in this level, of course, this is a much what can I say, easier level, is first level this is. And of course, as we go in the upper levels, then of course much more tougher problems exist. But that is not the point. The point is to show that, whether an average student like me, of course, my record in mathematics has been really poor. So is it possible for me to, or rather any average student, to rather, directly solve and at least get out through the first stage? I know there are many tougher stages as well, but I think this is a good start. So so I hope the aim or motive of this video is clear. So let me, without wasting any time, let's just start this video. So this is the instructions page, right? So if you want, you can just give a reading through it. But basically, they have the only thing that actually it matters to you currently is that questions 1 to 10 carry 2 marks each, 11 to 23 marks each, and 21 to 35 marks each. So of course, as you can expect, that the level of questions in the first 10, it will be much more easier than the last 10, right? So, and of course, the all questions are compulsory and no negative marking. So that's one good thing, which of course will benefit us greatly. Let me just see if you can actually, whether you can actually see what I am doing. Otherwise, it would just be a waste of time. Let me just wait for a minute. Yeah. So right, so I have zoomed in a bit so that it's you can actually see it properly. So let's just directly start, right? So it's going to be a very fun journey, right? So the very first question is of course again very easy. The thing is, you need to understand that these exams are given by from grades 8 to 12. So of course the difficulty has to be, between these, right? So of course some questions do go above it, but it's fine. So the very first question is 60% of a number x is 40. Then what is x percent of that number of 60? So if you can directly apply the logic, then 60 by 100% of let's say the number x, let's say the number is x, right? So they have given it is equal to 40. Then if you just find out it, x would be 400 by 60. So 400 by 6. So basically it's normal just equation solving. So 400 by 60, 400 by 60, this is the x value of x. So x percent means basically you divide it by 100 and multiply it with 60. Please ignore my handwriting again, lack of stylus. So 60 cancels out, and this also cancels out. So that would give us about 40, right? So the 60, 60% of okay, so this would be 4,000, right? 4,000, another zero would be there, I missed it, sorry. 4,000 by 60, so 60 just cancels out from here, and another two zeros cancels out, and hence the answer would be 40. So of course the first question is a really easy questions, sorry, really easy question, right? So it's just simple percentage multiplication. Just 60% of that number, let's say x, is 40. So you just write 60 by 100 into x is equal to 40. And again, the second is just put put the value of x and then just find that percentage of 60. So of course it's not a really tough question. So of course we are not going to much be going into detail, but I hope you get my point. This is a, of course, if we now some people might directly, after seeing this much of the video, they will start commenting that this is not actually Olympiad level. However, if I let me show you the, last few questions. So the last few questions are really, what can I say? Of course, maybe not very tough, but of course tough as in the sense that for especially an average student like me, if you are not able to solve this easily, then of course you don't need to watch this video. But listen, if you are just, already taught all these and without even using your own brain, then that's of course is no use, because the main purpose of this video is to teach you how to think fundamentally, right? So that is my aim, right? So let's just go back, right? So the first question again is well, it's a really easy question. So we did this. So now the second question is the find the number of positive integers n less than or equal to 100, which is divisible by 3 but not divisible by 2. Okay. So positive integer. So first thing is this positive integer. So of course zero will not be included. So we will start with 1, 2, 3, and all those all the way to 100. However, it is given that these numbers should be divisible by 3 but not divisible by 2. First, what would be the numbers divisible by 3? Right. So basically the factors of 3, or sorry, the multiples of 3. So 3, then what, 3 1 the 3 2 the 6, 3 3 the 9, just basic tables, and all the way up to whatever number. Let's write a few more so that it's more clear for you to understand. Let's say 4 3 4 that is 12, and again then again let's say 5 6 are 15, and then again 18, and dot so on, right? So that is the, the numbers which would be divisible by 3. So basically they are of course again moving at a gap of 3. However, it is given but it is not divisible by 2. Hence, among these numbers, see what is divisible by 2. 3, of course, is not, because it's a prime number. 6 is divisible by 2, so we reject 6, right? 9, of course, is again not divisible by 2 because it's odd. So, again, but 12 is rejected. Similarly, 18 is rejected. So can you just see what we are doing is that we are rejecting the even multiples of 3, right? So what are the even multiples of 3? 6, 12, 18. Can't you just see that it's a table of 6? So 6, 12, 6 ones are 6, 6 twos are 12, 6 threes are 18. And let's say the very next term of this would be what, 21. And then would be 24. 21 would be taken into account because it's an odd number, and 24 would be rejected. And hence 24 would be this. So like 6 4 the 24, right? So basically what we are actually doing is that, let me just rub this off. Yeah, so what we are actually doing is that we are just excluding the factors of 6, or basically the multiples of 6, from this list, right? So basically we have the whole table of 3. You can understand it like this. So we have the whole table of 3, and what we are actually doing is that whatever the even number, basically the multiples of 6, we are just cutting it out, cutting it out, cutting it out, and the rest we are getting, and we need to count how many of them. So, of course, one very brute force method is just writing down all the factors up to, let's say, 100. And of course, it won't take much time. Maybe, of course, you need to do much tougher questions. So, I would rather advise not to do this. But if you still want to do, but then, of course, if you just, that's method one, right? That's just brute forcing method, that okay, 3 9 3 6 9, you just write all the way up to 100, just multiples of 3, and basically just reject or cancel out the even ones, basically the multiples of 6, and just get your answer, right? So but of course, exam it's very tedious, especially if you want to do other questions at first, faster, because the later questions involve much more trouble, right? So the second method, however, is a bit of involved with sequence and series, AP and AP basically. So basically, we would be using the facts of AP here, but I know I told you in the before that this AP, we can think without AP also. That is method one. That is fundamentally solving, basically just brute forcing, of course. But the second thing is, like if I took a full course, then I would make make it more understandable to you. But basically, the thing is, of course, I hope that if you are giving this exam, you do have a knowledge of AP. So basically, AP is just nothing. It's just basically the common difference, right? So basically, we'll see that each and every number vary by a common difference. So let's say this number is by 3. This number is again increases by 3. This number is again increases by 3. So this type of sequence we call it as AP, right? So that is AP, and a few facts associated, or rather, we will not use facts. We will think fundamentally, right? So basically, the AP is that thing that the difference between two consecutive numbers in a series is just same for all the numbers, right? So the nth term and the n minus one term, if we take the difference, then it would be the same, right? Similar for other, let's say you take second term and first term. Let's say you take fourth term and fifth term, then the sum of two consecutive terms would be, sorry, the difference of two consecutive terms would be the same. That is the definition of AP, right? So we'll use this definition itself to rather get to a result, and we'll finally see what actually, how are we actually doing, actually how are we approaching this problem, right? So, so now what we can do is that, first of all, actually, we found out that what we actually need to do, right? So now what we need to do is we need to find the total number of, what can I say? Method one was just brute force, BF. Let me just write brute force. Method two, however, it's much more easier, and it. I mean, it's similar, but if you already know the knowledge of AP, then it would be much more easier, right? So. uh let's say we have 3, and let's say 6, and again 9. So these are all the multiples of 3. So we have to find that the number of numbers n, that is less than or equal to 100, right? So how many numbers are, basically what would be the last number of the series? So see, the maximum possible number should be 100, but of course 100 is not a multiple of 3, so we cannot count 100. However, the very what can I say, previous number, 99, is however multiple of 3, and also it's not, what can I say, not even number, not a multiple of 6. Hence we can just directly write that okay, the last term of this series would be 99. So how many total terms are there? Can you just identify by looking at a bit? Hmm, might be not, but let's say, so this is where the knowledge of, you can say, AP comes into play. in AP, or rather, don't care about AP. Okay, so what is this, right? So this is the first term, right? So this is sorry, 3 into 1, right? What is this? This is second term, so 3 into 3. So the third term, as you can see, is 3 into 3. Sorry, 3 into 2, that was. And the third term is 3 into 3. And the 99th term, just see how much. 3 into 33, right? 3 into 33. Hence, there are total 33 terms, because just observe this is just pattern, just see the pattern, right? So the first term was 3 multiplied the term number. So this is 3 again multiplied by term number, which is 2. This is 3 multiplied by the term number, gives this total third number, which is 3 into 3. And however, the 99, so of course you need to multiply it with 3, and 33 will be the total number of terms in this, right? So there will be 33 total, right? However, the thing is, we need to also subtract out all these multiples of 6, right? So this needs to cancel out and all. Let's say multiples of 6, how will it go? Will 98 be divisible by 6? And it will not be divisible by 6, right? So if you can just calculate, then I think 96 will be the last term, because if we divide 98 with 6, then I how much will be 98 and 6? So that means how much ones are, so 1 means 6 and 2. Oh, okay, not divisible. So let's see, 96 is whether divisible by it or not. So 96 is how much? 6 6 ones are 36. Yeah, so 96 is divisible. Hence, the last number of the, what can I say, the table of 6 is 30, is 96, because why? Again, we need to find the numbers less than 100. So of course it needs to be less than 99 also, because the total last term is 99. It cannot be 98, because 98, if you divide by 98 is not divisible by 6, right? Right, so 98 is not divisible by 6. Hence, we, neglect that, right? And also, you can directly say that 98 is even, so we cannot take it, right? So 97 again. However, the 96 would be the last term of this table of 6, right? So, let me just write the so called AP, or the table of 6, right? So, what was the table of 6? 6, 12, and then how much? 18, right? And then again, what 6 for the 24, right? So all the way up to 96. So from here you can also identify 6 into 1, 6 into 2, 6 into 3, this is 6 into 4, and you can just divide 96 by 6. So how much does it come? 96 by, sorry, 96 by 6, so that comes out to be 16, because if you just multiply 16 6 are 18, sorry, 6 6 are 9 6 9 are, okay, yeah, so that would be 16, yeah. So you can just multiply, basically you can just divide it by 6 and see that it would be what can I say, sorry, it would be 16 into 6, just multiply 16 into 6 and see what is coming, you will get 96 itself, right? So basically there is a total of how many terms? So of course 16 terms here, and so 16 terms here, and of course the total number of terms in the the table of 3, the entire table of 3 was 33. However, we had to exclude this number of terms. So we have to exclude 16 terms, right, from this. So what we will get, we will 13 minus 6, and that's 7, yeah. So we will get 17. The answer to this question will be 17. Of course, it's a very easy question, but the reason I'm explaining this is because you need to understand how exactly are we doing it. Because if you don't know AP, then how will you do? It's just finding patterns. Just if you first write down the table of 3, you will find out that the maximum number possible is 99. So that would be the 33rd term, because we just found out the pattern. And now we have to remove the multiples of 6. So when we remove the multiples of 6, the very last term could be 98 and could be 96 also. Might have not been 96 also. If 96 was not divisible by 6, it would be, probable chance would be then 94, right? However, 98 is not divisible and 96 is divisible. So that would be the greatest in the table of 6. So that's how many terms you have to basically subtract 16 from this, because this had to be removed, so total 16 terms here, so this had to be removed, and total there was 33 in the total table of 3, and hence we subtracted. So I hope it's again a very very easy question, but just for the sake of understanding, it was what can I say, a bit of tough, you can say, but tough in the sense that if you already don't know anything about this, then it would take a bit of time to think. but that's the purpose of this video. So let's just clear this up, and I hope this method 1 and method 2 are clear. Of course, if you are just not able to do it by this kind of thinking, then of course you can of course always choose brute force method, right? So hmm, fine. So now that is the second question done. The third question, yeah. So an integer-sided rectangle has area 20. What is the minimum possible value of its perimeter? So 20, it's just see. So what if you consider the length of the rectangle as L and breadth is B? So that is just LB equal to 20. So if you can just find out the factors of 20, then it would be all. So what will be one combination is 1 into 20. See, ultimately in perimeter we need the value of L plus B. It need not be distinct. Like it is like what can I say? Without the loss of generality. Without the loss of generality, we can write L as 1 and B as 20. So as it is mentioned that it is integer sided. If it was not integer sided, let's say I give some side as 5 by 20 into let's say 20 by 4. Sorry, yeah, into 5 into 5 into sorry into 20 by how much? Whatever, I hope you get the point that if the side was not integer, then we cannot just write that 1 into 20 and 20 and 1 and 1 into 20 is literally the same thing, because we need to find the area. So area is just the length plus breadth. If you just add them up, then you will get 21, right? So that is one thing. And there is LB, right? So LB is 20, and let's say the second thing is that how much? The next factor is 4 fives are 4 fives are is what 20. So if you add them up, you will get 9. Another thing is you can either take 2 or 10. So those are all the factors. Other than that, you cannot take 20, because just just prime factor is 20. See what you get. You just get 2, then you get 10 here, then 5 and 2 again, right? So what is the possible combination? Take these two and this, or rather take these two and this, or rather just take this and another one, 20 into 1. So basically these are the only possible combinations. Why? Because of the integer, because they are the only because they are only integers, right? That is the total combination. So how many combinations? Sorry, this is the of course the if we are finding the minimum perimeter, as it is mentioned, minimum perimeter. Of course, this value is minimum, right? So L plus B. See, perimeter is what 2 into L plus B, right? So the minimum value should be just L plus whatever the minimum value of L plus B. That would give us the minimum perimeter. That is why 4 plus 5 is equal to 9, and of course, hence this pair is what can I say? The minimum perimeter. So how much would the minimum possible perimeter would be just 18, right? So again, the question number 3 is also again a very easy question, of course, because this is the beginning. Um, but I hope you get my point, because the L into B is just 20, and you just find out in all the possible ways you can write the value of 20 as a factors. So you just break it down. You can rather prime factorize, or you can just rather use common sense, whatever you prefer. But if they are asked maximum perimeter, then of course it would be 21, 21 into 2, so that would give us 42. So I hope the third is clear, right? So let's move on to the fourth question. The fourth question says that the isosceles integer-sided triangle. Again, this integer-sided thing is very important, because other than that, if this the integer thing was not given, we would not have. Let's say let me take an example. Let's say we have 200, and another side is let's say 1 by 10, let's say, which is of course not an integer. So of course again the area is again coming out to be 20 itself, but as it is not an integer, 1 by 10 is not an integer, 0.1 is not an integer, and hence we cannot take that combination, right? So that is a very important thing, that it has to be integer. Otherwise we would not be able to solve it, right? We would be able to solve, but again that would involve the concept of AMGM, but again not going into that. Okay, how many isosceles sided triangles with a perimeter 23 are possible? So again, let's just consider any random triangle. Let me consider this. Of course it's not looking like isosceles, but let's just take this is A, and let's say this is again A, and this is C. So what we have to find the perimeter, right? So what would the perimeter of this figure, like 2A, 2A plus C, right? Let me just actually I don't have a stylus, so of course I got a bit of problems here writing, but no issues. 2A, because just A plus A and plus C, so 2A plus C is just equal to 23. So this is your condition, right? Because of course, you because you need to understand that you if the two sides are isosceles means basically any two sides are equal. So I've just assumed that these two sides are equal and the perimeter will be what, 2a plus c equal to 23. um and okay, so now these are integer sided, so let's say again we take combinations, right? So a, what can be a, what can be a, what can be, let's say a and again c. So very first restriction is that let's say the perimeter is 23. Okay, in general let's say the perimeter is 23, right? So the first thing you need to realize that 23 would give us so many combinations, right? Let's say 23 will give us 1 plus 20 plus 1, because we need to basically have three sides, so three partitions we have to make. So 1 plus 20 plus 1, we could have made that partition. Or we can even do 1 plus 19 plus 1, 19 plus 1, sorry, 1 plus 19 plus how much? 2. That then that would sorry, 1 plus 19 plus 3, again that would give another combination. Can you realize that if you just go on breaking down 23 by the brute force method, then can you realize how exactly how long it would be? Like it would just, what can I say, it would be all over the place and you won't be able to actually complete it, right? So that's the thing. So of course this is not a very feasible method. However, one condition we have been given which is very helpful to us is that these two sides would be equal. So let's say if this is one, this has to be one at all costs, right? If this is one, this has to be one at all costs. If this is two, this also has to be two at all costs. Then of course, our, what can I say, the number is reduced, the number of combinations is reduced. Otherwise, let's say we take this as one. Let's say we take this as three, we get another combination. Let's say we take this as one, and let's say we take this as two, and we get another combination. So of course we are not, it's good that it's not given like that, because that would be just infinite. No, of course not infinite, it would be finite, but it would be too long for us to calculate, right? So 1 and 1 and again 2 and 2. So what can be the possible value of c here? So the total area you know is what, 23. So what would the rest would be? Just 21, right? So 21 and 23 minus 1, 19. Just basic what can I say, common sense, right? So basically whatever the total sum should come out to be 23. So just see, 1 plus 1 2, 2 plus 1 21 is 23, 2 plus 2 4, and again 4 plus 19 4 plus 19 is 23. So really not so tough, right? So however, you might be thinking that even by this, let's say I will have to go 3, 3, and then 4, 4, let's say all the way, let's say 10, 10, 10, 10, and 1. 10, 10, and 1 will give what? 10, 10, and 1 will give 21. Let's say I go 12, 12, 12, 12 will not be. So you will think that 11, 11. So 11, 11 is how hard? So 22, 22 plus 1, right? So, sorry, 10, 10, 3, and 11, 11, 1. So you will think that okay, total there are 11 combinations possible. Total 11 combinations are possible, because because it will go all the way to 11, because if we take 12, 12, then 12 plus 12 is 24, and the total perimeter should be 23, and of course it cannot be minus 1, the side length. Hence, for the side length to be valid, it has to be 11, 11, 1. However, a slight problem that arises exactly here is that what can I say? If you already know it or not, I don't know, but you should that there's a property involved that in a triangle, that the sum of any two sides of a triangle should be greater than the third side, right? So how does that affect our answer exactly? So why does it actually matter? Let's just see. So let's take the very first example. We have assumed that okay, so 1, 1, and 21. So let's add any two sides. So let's add this, right? So a plus a would be what, 2, right? And c is 21. But we know that the sum of two sides of a triangle should be greater than the third side. That's just a property. For now, I know it's really terrible that each and every problem I'm telling you that you need to remember this property, and it's very much frustrating that how will I know? But the thing is, these are kind of constructed ideas, because in exam, if you just went, it can be of course easily proved, but of course I'm not showing it now, because if in exam you are actually doing this, it would take a lot of time to actually get to this, thought, or get to this theorem that okay, all to any sum of any two sides of a triangle is greater than the third side. So now I am using that fact as a result, but you should of course know where it came from. And if you just tell me in the comment section, then I would also gladly tell you the proof. But for now, let's say you add these two. So a plus a would be what, just 2 itself. Um, and see, the 2, however, is not greater than 21. So of course this combination is rejected. Now some people might say, sir, if we add these two, then that would be 22, and 22 is greater than 1. So that thing is correct. However, the sum of any two sides should be greater than the third side. So if even if we take these two, the sum should come greater than the third side, right? However, it is not coming, so we reject this case. Similarly, for let's say this case also. This case also again, what would be the sum of these four, and this is again reject. And as you can see, six, and that would be what? Of course, 23 minus 6 is how much? If you can see, just falling down by 2. So let me just, for 1 second, yeah, 23 minus 6, yeah, so 23 minus 6 would be just 17. So basically, because it's just falling by 2, so 17. So again, as you can see, sum of two sides is not indeed greater than the third side, so just reject it. So now you might be thinking, sir, then what we will actually do now? Because again, we had rejected this case. However, uh, consider 4 and 4. What would be 4 and 4 plus 4? 4 plus 4 would be 8. And what would be the perimeter then? 23 minus 8. To 23 minus 8 is what? 15. 15 plus 8 if you do. So again, that is also rejected. And let's say you take fifth, 5. Let's say you take 5. 5 plus 5 is 10. Let's say you take a as 5. So 5 plus 5 is 10. And 23. So that would be 13, right? So again, that case is again rejected, because if you sorry, if you take 10 and 13, sorry, 5 plus 5, you add them up, and it would of course be less than 13. So again, that's rejected. However, now the main thing, if you take 6 plus 6, right? So 6 plus 6, however, will give 12, right? So 6, let me write it here, or rather, yeah, 6 will give you, but the total sum of them will give you 12. And if you subtract 23 minus 12, you will get what? 11 itself, right? So just 23, just subtract, so you will get 11. So clearly the sum of two sides is coming greater than the third side, right? So so you will take the case of what can I say, 6, 7. So as you can see, even this also, just add them up, we will get what? 22. 22 again will be greater than 1. So that is 2. And of course, you can again take these two as well. So 11 plus 1, 11 plus 1 is 12. 12 is greater than 11. So again, that is true. That should be true both ways, not only one way, right? So 6, and see, let me take this one example, it will be clear. 6, and what would the other side? 23 minus 12, basically 11. So you take these two. 6 plus 6, 6 plus 6, 12. So okay, 12 is greater than 11, fine. Check these as well. 11 plus 6, sum of two sides, 11 plus 6 is how much? 17. 17 should be greater than 6, and it is. Hence, this combination is possible. So the combinations how many? 6 you take. 11 was also possible. That means 6, 7, 8, 9, 10, 11. Up to 11 it is possible. So how many? 1, 2, 3, 4, 5, 6. So total 6 combinations were possible. So hence, how many triangles total? 6, right? So again, a bit of thinking question. These questions I especially like, because it's just you're using your brain and not something external. It's just using your common sense basically. If you already know what the main thing was required here was that that what exactly is the property of this, that sum of two triangles, because otherwise if you didn't know this, you would report the answer is 11. However, as you knew that yeah, that the sum of two sides of a triangle should be greater than the third side both ways, then you rejected the few cases which were of course not holding true, and hence you arrived at the answer, which is 6. So again, I hope that bit is clear. I hope I could teach you how exactly do we get to this solution, to this answer, right? So again, let me just clear it up. I know it might be, it is a bit of time taking, because I'm rubbing it off and the size of rubber is not much large, right? So please ignore that time wastage and just skip forward. uh, Or rather, I think I could just pause and then rub it off and then continue. So now let's look at the fifth problem, right? So fifth problem, what it tells us is that how many three-digit numbers A, B, C in base 10, of course, are there with A not equal to 0, and of course A should not be equal to 0, because if A is 0, then it won't be three-digit, right? So that is the, I don't think that's much of use. Uh, However, they have also given that C is A plus B, right? So A, B, C is a number, and C should be A plus B, right? So that means, see, see each this A. Can you tell me the range, or can you tell me the how long? But basically, what values of A can be there? Hmm. See, A cannot be zero, but A can be one, two, three, four, so on. B can be zero, so B can go from zero, one, two, three, up to nine. Nine places it can go. And similarly, C also can go up to nine places. Why? Some see, because digits are only what, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Don't tell 10, because how can 10 be a digit, right? So of course C cannot be equal to 10, because 10 is not a digit. So digit is just that position number. So it can either range from 0 to, so it can range from 0 to 9, right? So what happens is that C should also be a digit, and hence this value of C can be 0 to 9, anything, right? So, however, we have been given that C is equal to A plus B. Let's say we take A as 9, B as 8. Then 9 plus 8 is how much? 9 plus 8 is, just add them up. 9 plus 8 is just 17. And of course, C cannot be 17. C has to be 0 to 9. So that's a hint, big hint we have, is that this value of C should be, just a minute. Yeah, this value of C, or rather the value of A, C should of course be, I mean, C should of course be less than 9, because less than equal to 9, because it can be 9 as well, because that is a maximum. How then we have this condition that A plus B should be less than equal to 9. Why should A plus B less than equal to 9? Because C should also be a digit. That's the thing. That's the, what can I say, twist. Because otherwise infinite numbers, infinite, not infinite, infinite are they? No, of course not infinite. They are finite, but there are infinite number of choice, like a very large number of choices, right? So if permutations, combinations. So if this is a three-digit number, this will have eight choices. Sorry, this will have nine choices. This will have eight, sorry, again 9, and again 10 and 10. So okay, leave that. The main, just keep in mind that there will be a large number of choices, right? So what we want to find is that, see, but the main reason this had been given was that C should also be a digit. So the value of C should lie between 0 and 9, and hence she should be less than equal to 9. Therefore, this value of A plus B should less than equal to 9, and that's now very big hint. So of course A can't be equal to 0, so we reject that case. So let's take the value of A as 1. So if A is 1, can you tell me how many possible values of B are there? So A plus B should be less than 9. So B can range from anywhere between 0 to 8, right? So basically, how many? Nine choices? Because 0 to 8 is nine choices. Don't make the mistake of counting that 0 to 8 number is just, what can I say? 0 to 8 is 9 choices, because see, 0, 1, 2, 3, 4, 5, 6, 7, 8. So 9 choices in all, right? So 0 to 8 is 9 choices. So basically, if we have A equal to 1, we get what? 9 choice. Let's say if we get A equal to 2, then again we get how much? 0 to 7, of course, because the total value should be maximum 9. Maximum 9. It cannot exceed 9. It should be less than equal to 9. So, how many maximum values possible? Then again, 0 to 7 is 8. Can you see that if you take A equal to 3 again, how many values possible? 0 to 6. 0 to 6, so that's 7. That is 7. So, similarly, if you just keep going on, let's say at A equal to, of course, again, maximum value of A can be 9. So, for A to be 9, B has only one choice. B should be only 0. Only 0, that means only one choice of B. So can you see how many total numbers are there? Basically, just add them up. For each case, for a equal to 1, there are 9 cases. A equal to 2, there are 8 cases. A equal to 3, there are 7 cases. All the way up to a equal to 9, there is only one case. So just, and I hope you can see that this would be 6, this would be 5, this would be 4, this would be 3, and then we get 1. So just add them up. So 1 plus 2 plus dot 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 9. So if you just know that the sum of natural numbers, or you can directly do 9 into 8. Uh, Sorry, just a minute. So basically, you just count 9 plus 8 plus 7 plus 6 plus 5 plus 4 plus 3 plus 2 plus 1, right? So, how can you count easily this thing? See, uh, if you know that the sum of first n natural numbers is n into n plus 1 by 2, basically what you can do is 9 into 10 by 2. 9 into 10, 9 into 10 by 2, then you get 9 fives, so basically that's 45. So hence total 45 numbers are possible. So I hope this is clear to you, because the see, the maximum value the value of c should also be a digit, and hence for it to be a digit, its maximum value can be 9, because if it cannot exceed 9. So a plus b, the net value of a plus b should be 9 itself. So if a equal to 1, we have just made cases. So if a equal to 1, then we get b equal to 0 to 9. That's total 9 cases. A equal to 2, we get 8 cases. Equal to 3, we will get 7 cases, and all the way up to a equal to 9. B can only be 0, so there's only one case for b. And just add all the cases up, and you will see that you will get 1 plus 8 plus all those. First, basically 1 plus 2 plus dot 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 9. So this is the first sum of first 9 natural numbers. So just again, just use the formula n into n plus 1 by 2, or rather, if you want a quick, you can say trick, that 1, 2, 3, and also write some numbers from backward, that 9, 8, basically just take them together. See, 9 plus 1 is 10, 2 plus 8 is 10, 3 plus 7 would be 10, right? Take them together, and just you will find out that you will get 40, and 5 will be remaining in between, so that would be just 45, right? So just add them up, and you will get the answer 45. So again, what can I say, simple question, of course. A much tougher questions to come. So now, let's move to the sixth question, and let's see what exactly does it tell. So moving on to the sixth question, we have that. So actually, I just solved it here. I am actually also, before, because I, of course, I am also doing it for the first time. I have never done this before, right? So I am also doing it for the first time. So I have solved it here, of course. Like, I mean, I solved it, and I got to some, some, basically some equation, which I will of course explain how I went there. And actually, I don't have the solution key right now. Otherwise, I actually don't know whether the problems we did is correct or not. But I think there should not be any conceptual errors, because if it is, then I will, of course, again, I will rectify in the comment that if any errors are there, right? So now moving on to the sixth question, we have been given that the height and the base radius of a closed right circular cylinder. Okay, so we have basically have been given a cylinder, right? So is it closed or open? Okay, closed, right? So it's closed, open, closed cylinder. Oh, sorry, yeah, it's closed cylinder. So let me just denote it by this. And the base and height radius are positive integers. So this is h, and this is r. So it is given that h and r belong to an integer. Now this is a very very important thing, right? In previously all these things, we use the fact that they should both be integers, so we should use the fact here also, that all these numbers should be integers, right? All these h and r. So and it is given, and its total surface area is numerically equal to its volume. So what would be the volume? Just pi r square into h. So basically the area of base, basically what, pi r square. So pi r square, h is the volume. And what is it? It is telling it is the total surface area. Total surface area is what? 2 pi rh. So for the cylinder, it is 2 pi rh, and for the upper two circular kind of discs, it's pi r square plus pi r square. So 2 pi rh plus 2 pi r square. So 2 pi r, if we take common, 2 pi r h plus r, that is the total surface area of the cylinder, right? So now just cancel out pi and r, and what we end up with is that rh is equal to, how much, 2h plus 2r, right? So yeah, so now we have fine, we have ended up with rh equal to 2h plus 2r. So now what? Like now we have to see what it is actually asking. So it is asking that its volume is some k pi, where k is a positive integer. So for that we need to find r and h, right? Without finding r and h, we cannot comment on it, because some people might say that if we can indirectly find h plus r, then that would also work. But you need to find r into h plus r. So in basically you need to find r and h itself, because if you get r and h, if you, what can I say, if you get the value of RNH, then just substitute. And there might be many values of RNH, we don't know. But whatever will be the value of RNH, if we get the value, and we will put the value of RNH here, and we will then get the answer easily. And then we'll just find the value of K and report it. However, the main thing arises, the question arises that how can we proceed from here? So all this fine that, yeah, volume of cylinder is this, pi r square h, and total surface area is 2 pi r into h plus r. This is just fine. This is again basic maths. But now, sir, how do we proceed further? Uh, hmm. Basically, now we have ended up with this equation, RH equal to 2h plus 2r. So, directly by looking at it, feeling of AMGM may come, but of course, I'm not going into the feeling of AMGM, because AMGM is not, what can I say? It's just not, what can I say? It's behind, very much behind the all the my ideas which I have there. So, now the main thing is that I need to find R and H, right? So, for finding R and H, let's say what we can do is that, let's bring all this in one side, right? So RH minus 2H plus, oh sorry, minus 2R is equal to 0. So the moment you bring these two on one side, you will just see that you can see a common factor here, right? So if you just take h common out of these two, taking if you take h common, then you will end up with how much, r minus 2, right? So r minus 2, so that's fine. And here you end up with minus 2r only, minus 2r equal to 0. Now, the thing is, how will this help actually? Because we have just found out that h minus r minus 2 equal to minus 2 r equal to 0. Why we did this? Why we did this? Because we just wanted to bring all these things together, in a, what can I say, in one side, right? So that basically we can directly take common at something, so that some factor is common. However, the thing is, see, if it would be very, fun, or it would be very good if then if we could get this r minus 2 as a factor, because let's say a and b are two numbers, and the product of them is 0. So either this is 0, or this is 0, or a and b both are 0. So if a and b multiplied together gives 0, there can be three possible cases. Either a and b both are 0, and 0 into 0 is 0. If a is 0, b is non-zero. A into non-zero, 0 into non-zero number is again 0. B is 0, a is non-zero, then also we will get 0. Hence, now our aim is that if we could somehow get the r minus 2 as a factor, then maybe we could equate it to r minus 2 is some, let's say r minus 2 is equal to 0, then we could possibly get the value of, what can I say, r itself. So we are trying to do that kind of thing. So we are trying to find, or basically we are trying to take r minus 2 as a common factor. Now, how can we take r minus 2 common factor? You will ask that, okay, r minus 2 is here, just fine. But here it is 2r. And of course, if we need to make here r minus 2, then first step is that just take two common outside, right? So basically, let's say we take two common outside, then that would be just r. But we need r minus 2. So my this is a very important idea. Just keep it in mind. If you feel that okay, you need it, just introduce it. Just make r minus 2. Who cares? Like, I mean, it doesn't matter. Just make r minus 2, and close the bracket, so that r minus 2 comes out. Now, you will say that r minus 2 I will make, so how can I make r minus 2? Because it's not given. What I all did was, from this I just brought it one side, and I got factored out h, and I thought that okay, r minus 2 if I could somehow make, then that would come out with a factor. But r minus 2 is not here. Originally r minus 2 was not here, it was just minus 2r. So what I did, I created r minus 2. So now, see, if when I created r minus 2, minus 2r is there, but there is a minus 4 also. Can you see that minus minus, so plus 4 I have added. So basically, I have subtracted, I have added 4 on both, I have added, yeah, I've kind of added 4 on both sides. So can you realize that if I just do minus 4 here, the equation would be just the same. Why did I do this? This is the main thing. People will just do this and they will say, yeah, it's just like that. Now, how will you actually hit it? That we take r minus 2, we, factor it like this. This is the reason why this is the reason actually this session is. I know this would be the last problem of the session, because again the time constraints is just the sixth problem. I know it's we have not done much, but the idea you will to get in mind. The next time we will do the session, we will, for the rest of the questions, we will be much more experienced, right? So what we are just doing here is that rh minus 2h minus 2r. So we took h common and we found out r minus 2. And now our wish is that if we could somehow factor out r minus h, and if we could do like this, that r minus h is equal to 0, then we would find out, the value of r and h individually. However, when we try to create r minus 2 here, of course it would not be in the, it was not here. So what I did is I just created it, and minus 2r was already there. However, there's an addition of plus 4. As you can see, minus 2 into minus 2, so plus 4. So I subtracted this minus 4 as well, so that the original equation is retained. Now it's very simple. Just take the common, right? It's now very simple. Just it would be just h minus 2 multiplied by r minus 2, and of course send this 4 to the other side. So if you send 4 to the other side, what you will get is so equal to 4. So now I will ask that, sir, now what is the point? Because ultimately what we got was this thing, h minus 2 into r minus 2 is equal to 4. If we could got that value as 0, then maybe we could compare h minus 2 r minus 2 is equal to 0, say h is equal to h is equal to 2, or r equal to 2. However, the point you are forgetting here, and that they have played game at, or basically you have missed it, is that these are positive integers. So that means h minus 2 and r minus 2 should also be integers. That means they should be the factors of 4, right? So what can be the possible values? 4, 1, or 1 and 4, or 2 and 2. Can you understand why? Now people will say it can be 1 by 4 into let's say 16 also. That's the thing. H minus 2 or r minus 2 cannot be 1 by 4, because they have to be integers, because it is given that h and r are integers, and if h and r are integers, then h minus 2 and r minus 2 is also integer. Basically integer minus integer is integer, right? So that's the thing. So can you understand? So exciting, just so brilliant this manipulation was. Now people will say, just practice and this will happen. How will it come with practice? Just understand this. Like, we just took all these variables one side, and we just took common, then found out, okay, r minus 2. Now we thought that, okay, if r minus 2 somehow we can create, then maybe we can do r minus 2 equal to 0, and then when we would find out. But when we do it, we take the factors of h minus 2 and r minus 2, then we get 4. Now again we get stuck, because see, if it was not mentioned that both are integers, then we would not have been able to write this, because it could be 1 by 4 into 16 also, that would also result in 4. But it is given that they're integers, hence the only possible cases are 4 into 1, 1 into 4, and 2 into 2 into the factors, right? So now it's just simple. H minus 2 is equal to 4. That means h is equal to 6. From this case, h is equal to 6, r equal to 3. H is equal to 6, r equal to 3. And from this case, h is equal to 3, r equal to 6. H is equal to 3 here, and r equal to 6. And from here, what? H is equal to 4, r equal to 4. Again, just simple. So can you see, these are the only possible values of r and h. Now we need to find we have got the value of r and h, and now we have to just find the volume, or basically, yeah, so we have to find volume, so r square h. So what is 3 squared? 3 squared is 9. 9 into 6 would be what? 54. From here we get r square h as 54. From here, how much? R square 36. 36 into 3 is of course less than 54, so of course it cannot be the answer. 4 square is 16. 16 4 is 64. Again, it cannot be the answer. Hence, the minimum value, because we have been asked the minimum value, as you can see. What is the smallest possible value of k? So as you can see clearly, the smallest possible value of k, which is basically r square h, is 54. Because if we do this, then we are basically finding out r square h, value of r square h, right? So just simply do r square h. 9 into 6, 54. 36 into 3, definitely less than, definitely more than 54. And 4 square into 4 basically is 16 into 4, basically that would be 64. So of course that also cannot be. So the minimum value of k should be 54. Can you imagine? This is the brilliance of the question. This is the thing actually which should actually have that. See, nothing extra was used. Just common, just formula of the volume of the cylinder and the total surface area. And the very thing we always do is that basically we try to take out some factor all those things. But we realize that if we could somehow factor out r minus 2, maybe we can find the value of r and h. And we did just that, and we arrived at only these three possible cases, and from here we found the minimum value of k and just substitute, and that the answer would be 54. So I would actually, I don't have the answer key right now, I have only the 30 questions. So I really don't know whether I have done it correct or wrong, but I hope it is correct. If it is not, then I would just, but I don't think it's conceptually wrong. Just see where if it is, no, conceptually it's everything is right. So I don't think it should be wrong, but I think that would be it for today's video. I know we only discussed six problems, but the motive, basically the workload or all the, what can I say, the thinking behind these six problems, you should make it very clear, and we will use this, in the future problems as well. Like we have all these questions left yet. So all these, let's say question number 7, 8, 9, 10, 11, 12, and all these are left here. We have not yet completed this. But I know we are taking much longer time to solve this. I know these problems, especially the first five, are actually not at all very advanced math Olympiad level. But the thing is, you just realize the thinking, this subtle things which you miss is the actual, what can I say, actual true math, right? So what we all did was we just solved these fundamentals. We did not even use the ideas of AP and all those stuff, which would of course make it faster. But now the aim of faster is not the, now the aim is not to become fast. Now the aim is to learn, right? So I hope this problem is also clear. Very brilliant problem again. Brilliant in the sense that this manipulation. Now people might give various kinds of name. You know what do they call this? That if you are getting more variables than equations, and you have been given integers, they say that it's some kind of Diophane equation. And people spend all those time reading all those theories and all. Of course, might be they necessary, but you can directly think it on your own. That's the point I'm trying to explain you. You can just think it on your own. This was just the first part, and we all have the next parts coming up, and which will, of course, we will increase the speed in the later house, because the first video I just needed to explain it to you that what we are actually trying to do. So this is how we will do the rest of the problems, right? We have many good problems. This, seventh problem is, eighth problem again, very interesting. I mean, analyzing, and the rest, the, especially this kind of problems I love. This kind again, basically it's just, common sense in the sense that we'll just have to use this problem and all those. It's really very interesting. We will do all of this in the next video. Please, if you found it helpful at all, I mean, of course, I mean, if you're already watching this, then might be you might know more than all of these six problems might not be very much tough to you. But thing is, can you really understand how math actually works? It's not like mugging up all these theorems or processes. It's just how you actually approach the problem fundamentally. Because this Diophane thing, we of course did not know. But the idea was that to create the r minus 2 as a factor, right? So I hope up to question number 6 is clear. So in this video, I will keep up to this. The next video, I will again give in 2 3 days, and then we would again solve the more tougher problems. With a much faster speed, because now we actually have, I have explained a lot more than what I was. I think I've over explained, but it's fine. For the next video, we will just increase the speed, and maybe next video we will do more than 7, 8, 10 problems. Maybe, let's see. So I hope it's clear. So I hope you really enjoyed. That was the point. Just enjoyment with true knowledge, right? So thanks for watching. Please tell me if it helped you and all. And of course, take care. Bye.